We introduce an interactive method for the creation of a wood-like appearance of polygonal meshes. The user has full control over various steps of the process, such as bark definition, growth function of the wood, and the appearance of cracks on the surface. In a first step, the triangles of the input model are converted into a tetrahedral mesh that is then extended using a biologically motivated growth function. The growth function defines the speed of the mesh development in the direction of its normal vectors. We simulate it with the deformable simplicial complex method. Stress on the surface can be initialized by predefined patterns or interactively sketched by the user. As the surface grows, the induced stress forms cracks in the surface mesh. The geometry of the input model is changed. Growth is either defined from the beginning or controlled by modifying the growth speed during simulation. A texture map can optionally be added, and the stress field can be sketched on the surface from an input image. This allows us to recreate crack patterns that resemble those of real bark. An important feature of our method is that the evolving object can grow around existing obstacles. Here we show various examples of woodified objects using different parameters of our system and different input textures. A side-by-side comparison between the initial and the evolved object shows their differences. Inverse growth can be used to visualize growth rings.